Welcome to the DevOps Architect track. This is month 1, and over the next 12 months you will move from being a senior engineer who can deploy a service to being the person who decides what gets built, what gets bought, and what gets killed. That is the architect role, and it is a different job. The premise of this track is simple. The platform you have inherited, or the one you are about to inherit, is a set of decisions someone made. Most of those decisions were not made consciously. They were defaults dressed up as architecture. The job of the architect is to surface those defaults, name the trade-offs, and put them in writing so the next person can change them on purpose. 12 months. 12 areas. Each month, you walk out with 4 pieces of paper that you can take to a meeting. By the end of the year, you have the artifact set that an architecture review board expects to see from a senior architect, a reference architecture, a set of keystone decisions in writing, a multi-region topology with named failure modes, a working POC, a team API, an SLO catalog, a security review, and an executive communication pack. Month 1 is the foundation. Everything else builds on it. Here is how the 4 hours are structured. Hour 1 is reference architecture thinking. We will cover the DevOps capability stack, source, build, artifact, deploy, run, observe, secure, and walk through 2 real reference architectures side by side, one cloud native, one hybrid. The point is that the boxes on the diagram do not change when the constraints change. The tools underneath do. Hour 2 is cloud agnostic patterns. The lock-in vs lockout spectrum, the abstraction tax, the 4 decision lenses, the migration test, the skills test, the standardization test, and the cost of change test. We will use the spectrum to map your platform components and decide where you should pay the tax and where you should not. Hour 3 is the architecture challenge. You will draft C4L1 through L3 diagrams for an assigned scenario, a regional bank migrating to AWS, a B2B SaaS adding a second region, a healthcare startup splitting PHI across Gove Cloud. 40 minutes. Pair share at the end. The diagram is not the answer. The trade-offs you name on it are. Hour 4 is decisions, multi-region, and communication. MADR ADR drafting for keystone decisions. Multi-region overlay with explicit RTO and RPO. 4-minute pitches with peer review. The 30-minute architecture review format that you can run with your team on Monday. The 4 artifacts you walk out with are a reference architecture, 3 MADR ADRs, a multi-region topology, and a working compositive 1 capability. Each one is a piece of paper you can take to a meeting. Let us start with the reference architecture stack. This is the model that holds whether you are on AWS, Azure, GCP, on-prem, or some hybrid of all 4. 7 capabilities. Source is where the code lives. Git, branch policy, signed commits. Build is CI, tests, lint. Artifact is the OCI image with its SBOM. Deploy is GitOps, Helm, cross-plane compositions. Run is Kubernetes, service mesh. Observe is metrics, logs, traces. Secure is policy enforcement and image signing. The point is, pick the capability first, then pick the tool. Source as a capability is versioned code with branch policy and signed commits. The tool is GitHub or Gitia or GitLab, interchangeable. Deploy as a capability is declarative workloads reconciled from a Git repo. The tool is Argo CD or Flux, interchangeable, mostly. When you name the capability, you survive vendor churn. When you name only the tool, every vendor change is a 6-month migration project. Why capability first? 2 reasons. First, it resists vendor churn. The capability, deploy declarative workloads from a Git repo, is what you need. The tool is a configuration change, not a rewrite. Second, it survives reorgs. When half the platform team quits, the architecture document still describes what the platform does. A tool named architecture tells you nothing about whether you have a deploy capability at all. What goes wrong without it? Stealth rewrites. Swapping Argo for Flux becomes a 6-month project instead of a one-line config change because the architecture never named the capability in the first place. Let us make this concrete. 2 real architectures, same capability stack, different constraints. Architecture A, a cloud-native fintech. Greenfield, AWS-only PCI DSS scope, single region today. Source is GitHub with branch protection and signed commits. Build is GitHub Actions with ODC to AWS, no long-lived keys. Artefact is ECR with COSIN image signing SBOM per build. Deploy is Argo CD app of apps with Helm, Carpenter for nodes. Run is EKS with Istio Mesh and ALB ingress. Observe is managed Prometheus plus Grafana plus CloudWatch logs. Secure is Kyverno for policy and IAM roles for service accounts. Architecture B, a hybrid telco, regulated. Brownfield, on-prem plus AWS, data residency constraints, multi-region. Source is self-hosted Gitia with signed commits and mandatory reviews. Build is Tekton on OpenShift with ephemeral runners. Artefact is Harbor Registry with COSIN and Cyclone-Dick SBOM. Deploy is Argo CD with customize overlays per environment. GitOps only. Run is EKS plus on-prem ROSA with Istio multi-cluster mesh. Observe is Thanos on S3 Loki, Tempo, and OpenTelemetry SDKs. Secure is OPA Gatekeeper, Falco Runtime, Vault for secrets. Same capability stack. Different tools in every box. Why? Constraints. The fintech can use managed services because compliance is satisfied by managed PCI-eligible services. The telco cannot. Data residency forces on-prem workloads that the cloud does not host as a managed service. The takeaway. Architecture A, managed services are the right default where compliance and pace matter more than portability. Architecture B, portability is the right default where regulation forces you to move. The boxes on the capability stack do not change. The constraints pick the tools. When you draw your own reference architecture, name the constraints first, then pick the tool that survives them. Tools chosen without constraints are accidents of which vendor your team knew first. Now let us talk about the decision nobody wants to make. Lock-in. There are 4 positions on the spectrum. Commodity, object storage, managed Postgres, DNS, message queues. Standardized, Kubernetes, OCI images, OpenTelemetry, Helm, Terraform. Differentiating, your platform golden paths, your IDP abstractions, your ML platform, vendor power tools, proprietary serverless like Lambda or Azure functions, vendor BI tools, vendor ML services. For commodity, use the cloud native. The abstraction tax of running your own Postgres for portability costs more than it saves. You will spend 2 engineers maintaining a database that a managed service gives you for 1/10 of the cost. For standardized, pay a small abstraction tax to keep optionality. Kubernetes is portable across every cloud. Helm is portable. OpenTelemetry is portable. The portable layer is one configuration change, not a rewrite. For differentiating, build and own. The abstraction is your product. If your competitive advantage is the platform, you cannot rent it from someone else. You will end up paying for the abstraction tax in vendor constraints instead of in engineering time. For vendor power tools, use deliberately and document the lock-in cost. They buy you velocity today at the price of an exit tomorrow. The price of exit is rarely a line item. It is a year of engineering you did not budget for. The trap is treating all of one cloud as lock-in. A fintech running EKS, RDS, ALB, and CloudWatch is not locked into AWS. They are using managed commodity services. The lock-in comes from the proprietary serverless and ML layer, and from the IAM and VPC configuration that takes a quarter to re-platform. Ask this: if you stripped out the proprietary services and kept everything else, could you leave? If the answer is yes, the lock-in is bounded. If the answer is no, you have a multi-quarter migration hiding inside what looks like a one-cloud architecture. Before you sign an ADR that locks you in for 3 years, run it through 4 lenses. Lens 1, the migration test. If a regulator forced you off this vendor in 18 months, what would it cost? If the answer is less than a year of engineering, it is acceptable lock-in for the differentiating layer. If the answer is more than 2 years, the lock-in is too costly. Pick a portable alternative. Lens 2, the skills test. Are the skills transferable to another vendor? Lambda expertise does not transfer to Azure functions. Kubernetes expertise transfers everywhere. If your team is learning a non-transferable skill, ask why. The answer is usually, because we did not have time to learn the portable version. That is a temporary condition, not an architecture. Lens 3, the standardization test. Is there a CNCF graduated or ISO standard alternative? If yes, prefer it for the standardized layer. The CNCF graduation process exists exactly, so you do not have to make this decision on your own. They have done the maturity review for you. Lens 4, the cost of change test. Can you change later without rewriting applications? If yes, you can defer the decision. If no, decide now. Most architectural debt comes from decisions that were deferred past the point where they were cheap to change. The meta rule: commoditize the commodity, standardize the standard. Differentiate only where differentiation is your product. Everything else is an accident of which vendor your team knew first. When in doubt, write the decision down as an ADR with reversal conditions. The act of writing reversal conditions forces you to admit what would change your mind. If you cannot write the reversal conditions, you have not made a decision, you have defaulted. Now we get to the diagram model. The C4 model was created by Simon Brown specifically to address a recurring problem: architecture diagrams that nobody can read. There are 4 levels. Each answers one question. Each is for one audience. Level 1. System context. What system is this? Who uses it? What does it integrate with? Audience: anyone. The CEO can read this slide. It is a single box with people around it, and the external systems it talks to. If your CEO cannot read your architecture diagram, you are at the wrong level. Level 2. Containers. What deployable units make up the system? Audience: engineers and architects. Names the boxes that run web app, API, database, message queue, cache. Each container is a separately deployable thing. Level 3. Components. What lives inside one container? Audience: engineers building that container. Names the modules, controllers, stores. You do not need to draw all components for all containers, only for the complex ones. Level 4. Code. Class and function level. Rarely needed in Arch reviews. By the time you are at this level, you should be in the IDE, not the meeting. If your architecture review is debating class hierarchies, the meeting has gone off the rails. The matching question for each level is the discipline. L1 answers what is the system. L2 answers what runs. L3 answers what is inside. L4 answers how is it implemented. When the audience changes, the level changes. When you show L3 to the CEO, you have shown the wrong diagram. 2 operational rules. First, version control the diagrams in Structurizer DSL, so the C4 view stays in lockstep with the code. A mermaid diagram pasted into a slide deck is already stale by the time the meeting starts. Second, every diagram carries a short prose narrative explaining the trade-offs. The diagram shows what? The narrative explains why. 40 minutes. Pick the scenario assigned to your table. 3 options. Scenario A. A regional bank wants to migrate 40 microservices from on-prem to AWS over 18 months with 0 downtime and PCI DSS scope. The constraints are regulatory and operational. The trick is the data tier, PCI scope forces separation, and zero downtime forces a strangler pattern with parallel run. Scenario B, a B2B SaaS company on a single EKS cluster needs to add a second region for DR after a 6-hour outage cost them a major customer. The constraint is asymmetric. They want reads in both regions but writes in one. RPO and RTO matter more than the architecture itself. Scenario C, a healthcare startup needs to process as sensitive PHI on AWS GovCloud while running normal workloads on commercial AWS, sharing one codebase. The constraint is regulatory and forces a split in the data tier and identity plane. One codebase, two operating environments. Pick the scenario. Then produce 4 things. L1 context, the system, the users, the external integrations. Names, not boxes. If a box has no name, ask whether it should exist. L2 containers, the deployable units, with the environment each one runs in, and the data stores next to each container. L3 components, for the most complex container, draw the modules, controllers, stores, gateways, sidecars. And risk markers, every container tagged with the top risk, data residency, vendor lock-in, blast radius, or single region failure. Rules. Diagrams in Structurizer DSL or Mermaid version controlled in the repo. Each diagram carries a short prose narrative. No vendor logos unless the trade-off is the vendor. When you pair share at the end, the question to ask is, what is the riskiest assumption your design? If you cannot name it, the design is incomplete. The riskiest assumption is the one that, if wrong, invalidates the architecture. Now we get to the artifact that will save you more pain than any other. The MADR ADR. MADR stands for Markdown, Any Decision Records. It is a lightweight template for capturing architectural decisions in writing, in a format that survives the meeting. The full template has more sections, but 4 do most of the work. Section 1, Context and Problem Statement. What forced this decision? 2 sentences. If you cannot write this in 2 sentences, you do not yet understand the problem. Section 2, Decision Drivers. What made the choice obvious in hindsight? These are the constraints you cannot change: regulatory, technical, financial. They are not the same as the decision itself. Section 3, Considered Options. At least 2. The loser matters. This is the section everyone skips, and it is the section that pays for the template. If the Considered Options section has fewer than 2 options, the ADR is hiding the loser. The losing option is what you will get asked about in 6 months. Write it down while you still remember why it lost. Section 4, Decision Outcome. The chosen option, with reversal conditions. What would change your mind? If you cannot list reversal conditions, the decision was not really a decision. It was a default dressed up as an architecture. Then consequences, positive and negative, and a pros and cons table that forces honesty about what you are giving up, and links and references, the trail back to the meeting that signed the decision. Without the trail, the ADR is a memo. With the trail, it is an artifact. The signal of a good ADR. Reversal conditions are explicit. The Considered Options section names at least one option you seriously considered. The Consequences section is not a sales pitch. It includes at least one thing that worries you. The link back to the meeting is dated and includes the attendees. The signal of a bad ADR status is proposed 6 months later. Considered Options has 0 entries. Reversal conditions are absent. The Consequences section reads like marketing copy. Most architectural debt comes from decisions that were not made, or were made by default. The keystone decisions are the ones that lock you in for 3 years. You must name them in writing, with options on the table. 3 keystone decisions show up in 9 of 10 architecture reviews. Keystone 1. The traffic plane. Service mesh or not? The decision is between Istio, linkered, or no mesh. The reversal conditions. MTLS is not in scope, or the operational cost of the mesh exceeds half an FTE per cluster. The considered options: sidecar mesh, sidecar-less with Cilium, no mesh with VPC level MTLS. Most teams pick a sidecar mesh for the first year and then realize they are paying an operational tax they did not budget for. Keystone 2, multi-cloud or multi-region single cloud. The decision is between AWS-only multi-region or AWS plus Azure. The reversal conditions: cross-cloud latency exceeds 50 ms/999 between application tiers, or a regulator mandates portability. The considered options: active-passive warm standby, active-active single cloud, multi-cloud with cross-plane abstractions. The cheapest correct option for most teams is active-passive warm standby. If you find yourself reaching for active-active multi-master, ask why. Usually the answer is, we did not want to do the capacity planning for active-passive. That is a planning problem, not an architecture problem. Keystone 3, the identity plane, SPIF, or Cloud IAM. The decision is between SPIF or Aspire, for workload identity, or relying on cloud-native IAM, like EM roles for service accounts or workload identity. The reversal conditions: multi-cloud requirement, or non-Kubernetes workloads needing identity. The considered options: SPIF, Cloud-Native IAM, OIDC Federation. Cloud-Native IAM is the right default for single cloud, single runtime. The moment you have multi-cloud or non-Kubernetes workloads, you need SPIF, the deliverable rule. 3 ADRs, each with at least 2 considered options, each with reversal conditions named. If you cannot fill the reversal condition, the decision was not actually made. It was defaulted into existence. The cheapest correct option for your business is rarely active-active multi-master. Most teams are above their budget for it, operationally, financially, and cognitively. 4 patterns: active-passive with warm standby, reads in one region, writes in one region, failover in minutes. RTO 5 to 15 minutes, RPO in seconds. The cheapest correct option for most teams. Active-active with read-only secondary, reads in many regions, writes in one region, failover in minutes, adds read capacity, accepts eventual consistency on the read path. The right choice when reads dominate writes by 10 to 1. Active-active with multi-master, reads in many regions, writes in many regions, failover in seconds. The hardest. Conflicts must be designed for. The right choice only when writes must survive region loss. And almost no business actually needs this. Pilot light, minimal reads, no writes until invoked, failover in tens of minutes. The cheapest. Longest RTO. Use only when RTO greater than 1 hour is acceptable. Most teams over-engineer for RTO 5 minutes, when their business would survive an RTO of 4 hours just fine. The handwave trap. Most multi-region designs say active-active in the slide and active-passive in the database tier. The slide is wrong. The database tier is the constraint. Force the consistency, latency, cost triangle to be explicit on every diagram. The principle. Name the RTO and RPO on the diagram, not in a separate doc. If the diagram does not show them, the design is not finished. It is a wish. If your RTO and RPO are not visible in the meeting, they will not survive the meeting. A test. Ask the team to draw their multi-region topology on a whiteboard without looking at the docs. If they cannot, the topology is not understood. It is documented. Understood is what survives a 3 a.m. page. The 4th deliverable is the working pokes. Pick one capability from the architecture you just drew. Build it. Commit by commit history shows your thinking, not just the final shape. 3 options for the posts. Option A, a crossplane claim. Build an XRD and a composition that provisions a namespace, RBAC, and service monitor from one claim file. This proves abstraction design and reconciliation loops, the heart of any platform engineering work. A claim is the input, the composition is the contract, the reconciled state is the output. Option B, multi-region DR. Build a cross-region RDS replica with an automated failover runbook and a chaos test that takes the primary region down. This proves you can hit your stated RTO and RPO. The POS is not, we have a read replica. The POS is, we tested failover in production-like conditions, and we hit our RTO. Option C, C4 as code. Build the assigned scenario in Structurizer DSL checked into Git, with a CI step that fails the build if a container is added without L1 documentation. This proves architecture stays in lockstep with code. The C4 diagram is not a slide artifact. It is a tested artifact. Deliverable. A Git repository with a readme that names the capability, links the relevant ADR, and shows the run command. No GUI, only pokes. If the poke cannot run from a fresh clone with one command, it does not prove what you think it proves. Rubric, 25 points across 5 criteria. The capability is named and scoped, 5 points. Runs from a fresh clone with one command, 5 points. Test or chaos, step proves it works, 5 points. Commit history is readable, 5 points. README links back to the matching ADR, 5 points. The point of the rubric. You cannot pass by writing a lot of code. You cannot pass by drawing a beautiful diagram. You pass by tying the poke to the architecture decision it validates. The POC is the proof of the ADR. 1 artifact, 3 lenses, 10 minutes each. Use the same meeting for an exec update, an engineering review, and a regulatory audit. 0 to 10 minutes, the executive lens. Lead with the C4L1 system context. State the RTO and RPO targets. Name the top 3 keystone ADRs. Close with the one decision you are asking for, named and dated. Output, a signed ADR or an explicit deferred decision in the meeting notes. 10 to 20 minutes, the engineering lens. Lead with the C4L2 containers and the data stores next to each one. Walk one keystone decision end-to-end, context, options chosen, reversal. Challenge every line on the diagram. Why this tool, not that one? What breaks if you swap it? Where is the data stored? The questions you ask in this 10 minutes are what separate an architecture review from a status update. 20 to 30 minutes. The audit lens. Show the MADR ADR repo. Show the Structurizer DSL files. Show the commit history. Trace the most consequential decision back to the meeting that signed it. Prove the architecture is reproducible from the repo, not from a slide deck. 30 minutes. Outcome. 1 of accepted, accepted with conditions, deferred to next review, escalated. Always. A date and a name attached to each outcome. Never. We agreed in principle. That is the smell of a default dressed up as a decision. The ground rule. If the meeting ends without a signed or explicitly deferred decision on every keystone ADR, the meeting was a status update, not an architecture review. Most architecture reviews fail this ground rule. Most architecture debt is created in meetings that did. Practice this on Monday. Pick one architectural decision that has been under discussion for more than a month. Run it through this 30-minute format. Sign the ADR or defer it explicitly. Watch how quickly the conversation changes when the meeting has a clock and a format. A fitness function is a test that runs in continuous integration and asserts an architectural property. Without them, the architecture decays by 1,000 small pull requests, each one a tiny violation that the compiler does not catch. 4 kinds of fitness functions. Architectural, assertions on the dependency graph. No cycles in the import graph. A service may not depend on more than 8 others. The function is no cycles, import graph, and max fan out. These stop the everyone imports the utils package rot. The rot is silent until the next refactor, when the codebase is too tangled to refactor. Operational assertions on production health properties that the architecture promises. P99 latency less than or equal to 250 milliseconds. Error rate less than or equal to 0.1%. Continuous integration runs synthetic probes. Pull requests that breach the service level objective are blocked at merge. Architecture is no longer aspirational. It is enforced on every change. Compliance and security, assertions on regulatory and security properties. European Union workloads stay in European Union regions. Identity and access management policies do not grant wildcard access or administrator access. The auditor sees a green continuous integration badge, not a 200-page manual. Process assertions that you cannot add a container or service without an L1 documentation update and a matching architecture decision record. This is the function that stops the architecture from drifting silently. The drift is what kills architecture reviews, not the bad decision, but the many good decisions that were not made. The principle: if the architecture is important, it must be testable. If it is not testable, it is not architecture. It is opinion. The same 4 failure modes show up in 9 of 10 first-time architecture decks. Name them out loud when you see them. Pitfall 1: boxes without trade-offs. An architect who draws boxes connected by lines, but cannot name one trade-off on any line. The symptom: every box has the same label, every arrow says calls. The fix: challenge every line. Why this direction? Why this protocol? What breaks if you swap it? If the architect cannot answer, the diagram is decoration. Pitfall 2: ADRs that hide the loser. The considered options section has 0 or 1 option. The decision reads as fait accompli. The symptom: we will use X because it is the best. The fix: demand 2 options with pros and cons. The losing option is what makes the ADR an artifact instead of a memo. Pitfall 3: multi-region that hand-waves data. The diagram says active in 2 regions. The database tier says primary in 1 region. The symptom: the write path crosses regions in production, but the diagram shows a single write region. The fix: force the consistency, latency, and cost triangle to be explicit on every diagram. The database is the constraint, not the diagram. Pitfall 4: proofs of concept done in a vendor graphical user interface. The poke that proves it works is a screenshot from a vendor console, not a repository. The symptom: no commit history, no README, no test that runs on a fresh clone. The fix: require code, commit history, and a 1 command run. A graphical user interface PUC proves the vendor works, not your architecture. When you see one of these patterns in a review, name it. Naming the pitfall is what separates a senior architect from a senior engineer. 4 artifacts, 100 points. Each artifact scores 25 points against 5 criteria. You cannot game one number to pass. The rubric forces 4 different muscles. Deliverable 1, the reference architecture, C4, L1 to L3. 25 points split across 5 criteria. Capability first naming, trade-offs named on every line, diagrams version controlled, C4 levels match the audience, and risk markers on each container. If your diagram has no risk markers, it is not a reference architecture, it is a logo wall. Deliverable 2, 3 ADR architecture decision records, 25 points, 2 options per ADR, reversal conditions named, consequences listed, linked to the meeting that signed them, stored in version control. The point of the ADR is not the decision. It is the trail that lets the next person challenge the decision. Deliverable 3, the multi-region topology. 25 points. Pattern chosen with rationale, RTO and RPO named on the diagram, data tier consistency model explicit, cost estimate attached, and chaos test in continuous integration. The chaos test is the difference between a documented topology and an understood topology. Deliverable 4, the working poke, 25 points, 1 capability, scoped small, runs from a fresh clone, test proves it works, commit history is readable, and the README links the matching architecture decision record. A POSI without a link to the ADR it validates is just a tutorial. Passing bar is 70 out of 100. Distinction is 85 out of 100. The point of the rubric, no deliverable can pass without naming the trade-offs. Drew a box is worth 0. Drew a box and named why it is not a different box is worth full marks. Month 1 gave you the architect lens, reference architectures, cloud agnostic patterns, C4, MEDR, multi-region, the 30-minute review. The next 11 months build on it. What you walk out with. 4 artifacts, a reference architecture at C4 L1 to L3, 3 MEDR ADRs, a multi-region topology with RTO and RPO, and a working POSI of 1 capability. Each one is a piece of paper you can take to a meeting. And 1 muscle, naming trade-offs. We chose X because Y, and we would switch to Z if W. That sentence is the unit of architecture. If you can produce that sentence, you can produce the artifact. Your offline milestones before month 2. Ratify your 3 ADRs with a peer reviewer and record the questions raised. Move your C4 diagrams to Structurizer DSL so they are version controlled. Run a 30-minute architecture review using the artifacts from this session. Add 1 evolutionary fitness function, 1 test for 1 architectural property. Read Team Topologies chapters 5 to 7 that sets up month 2 on internal developer platform design, and identify your platform's 1 riskiest cloud lock-in and draft a mitigation. Month 2 preview. Where month 1 was the what, the architecture, the decisions, the patterns, month 2 is the who and the how. Team topologies applied to a real platform organization. The platform engineering operating model, stream-aligned teams, platform teams, enabling teams, complicated subsystem teams. The team API as an architectural artifact, fitness functions for cognitive load. 12 months from now, you will have the artifact set that an architecture review board expects to see from a senior architect. The artifacts are the visible output. The muscle, naming the trade-off, writing the reversal condition, asking the next question, is the part they cannot take from you.